The map of Southeast Asia is a lie told by the Holocene. If we could peel back the turquoise waters of the Gulf of Thailand and the Java Sea, the familiar fragmented archipelagos of Indonesia and the Philippines would vanish, replaced by a massive, contiguous landmass the size of Europe. This was Sundaland. For nearly 2 million years, it was not an obstacle of islands, but a core of the human experience, a vast tropical engine of biological diversity and population expansion. We have long viewed the drowning of this continent at the end of the last glacial period as a local catastrophe, a literal Atlantis of the East that forced primitive tribes into the highlands. But genetic data is now dismantling the myth of the passive refugee. The DNA of billions of people living today suggests that the submergence of Sundaland wasn't just a loss of territory, it was the primary catalyst for the genetic architecture of modern Asia. The traditional narrative of Asian prehistory has always favored the out-of-Taiwan model, a clean, linear expansion of Austronesian farmers moving south, replacing or absorbing the hunter-gatherers they encountered. It is a story of cultural dominance written by the victors of the Neolithic Revolution. However, when we shift the lens from linguistics and pottery shards to the cold mathematics of mitochondrial DNA and whole genome sequencing, the direction of the current reverses. The molecular clock reveals that the most significant lineages in the region didn't arrive with the dawn of agriculture 4,000 years ago. They were already there, vibrating within the interior of a continent that no longer exists. By analyzing the distribution of Haplogroup E and other indigenous markers, geneticists have identified a massive population pulse that predates the rise of farming by several millennia. This wasn't a slow drift, it was a pressurized dispersal. As the sea levels rose by over 100 meters, Sundaland lost nearly half of its landmass. The environment didn't just change, it disintegrated. But rather than collapsing, the populations within this cradle underwent series of rapid admixture events and forced migrations. The map of humanity wasn't written in a lab, it was carved by the sea and the stone. This is Helix Horizon, where we trace the code that refuses to stay still. What we are discovering is that the genetic diversity of modern island Southeast Asia is far higher than that of mainland Asia, a biological reality that contradicts the idea of a simple one-way migration from the north. In population genetics, high diversity usually signals an older, stable source population. The submerged plains of Sundaland were likely a massive refugium during the last glacial maximum, a humid, stable sanctuary where human lineages didn't just survive the Ice Age, but thrived and diversified in isolation. When the melt began, this reservoir of genetic variation was breached, spilling outward in all directions. The flooding of the Sunda shelf was not a singular overnight catastrophe, but a multi-millennial erosion of a world. Between 15,000 and 7,000 years ago, 3 massive meltwater pulses, surges of glacial runoff from the northern hemispheres, rearranged the global coastline. In Southeast Asia, this resulted in the loss of nearly 2.8 million square kilometers of land. For the populations inhabiting the interior river valleys of Sundaland, the horizon didn't just move, it vanished. This environmental pressure created a biological bottleneck, followed by a massive outward radiation. By sequencing the genomes of indigenous populations across the Philippines, Indonesia, and the Malay Peninsula, researchers have identified specific genetic markers such as mitochondrial DNA haplogroups E and B4 that began their expansion precisely as the land was disappearing. This data provides a stark correction to the out-of-Taiwan hypothesis. While linguistic evidence suggests a southern expansion of farmers, the genetic evidence reveals a much older, more complex layer of human movement. The Sundaic lineages didn't wait for the invention of the outrigger or the domestication of rice to move. They were already shifting, driven by the literal shrinking of their universe. This suggests that the maritime skills traditionally attributed to Neolithic farmers may have actually been forged in the crucible of the Sundaland submergence, a desperate generational adaptation to a world that was becoming more water than earth. The genetic signals of these Sundaic survivors are not confined to the islands. We see their signatures as far north as mainland China and as far west as Madagascar. This wasn't a retreat, it was an inoculation of the surrounding land masses with a highly diverse, highly adapted genetic toolkit. When we look at the high frequencies of certain alleles related to breath-holding and oceanic adaptation in groups like the Baijiao sea nomads, we aren't seeing a recent curiosity of evolution. We are seeing the refined remnants of a selective pressure that began when the plains of Sundaland became the floor of the Java Sea. This reveals a fundamental principle of population genetics. Environmental instability is the primary engine of diversity. In the stable interior of a continent, lineages tend to settle into equilibrium, but on the edge of a drowning world, the rules of survival change. The populations of Sundaland were forced into constant contact, leading to admixture, the mixing of previously isolated genetic groups. This creates a hybrid vigor that can accelerate adaptation. The DNA suggests that the people who eventually settled the Pacific were not a single pure race of voyagers, but a composite population, a genetic mosaic assembled by the rising tides of the South China Sea. What the data revealed next changed everything. For decades, the presence of Negrito populations in the Philippines and the Malay Peninsula was framed as a relic of an ancient, failed migration, a group of first movers who were eventually marginalized by more advanced agriculturalists. This is a narrative of replacement that conveniently mirrors colonial history. However, deep genomic analysis shows that these groups share significant portions of their ancestry with the wider Southeast Asian population. They weren't replaced, they were the foundation. The genetic distance between these groups and their neighbors is a product of long-term relative isolation and genetic drift, not a difference in fundamental origin. The survival of these lineages throughout the submergence of Sundaland teaches us that biological continuity often persists even when cultural identity is overwritten. The shift from hunter-gathering to farming is frequently viewed as a total replacement of the old people by the new, but the DNA of a modern Indonesian or Filipino is a ledger of both. The farmer and the forager are often the same person, genetically speaking, separated only by a few thousand years of selective pressure and a change in diet. The submergence of the continent acted as a giant centrifuge, spinning these lineages together before flinging them across the Pacific. As the rising tides of the Holocene reshaped the physical geography, they also rewrote the genetic geography of the Pacific. The submergence of the Sundaland plains acted as a massive selective filter. Those who stayed in the highland refugia, today's islands, faced intense founder effects, where small, isolated groups became the genetic blueprints for future populations. This explains the distinctiveness of certain localized lineages that seem disconnected from the Asian mainland. But for those who pushed outward, the result was a population bottleneck, followed by a spectacular expansion. This expansion is often mischaracterized as a triumphant march of a single culture. However, the high-resolution genomic data tells a story of admixture that complicates the narrative of any pure ancestral line. In the genomes of modern-day inhabitants of Wallacea, the transition zone between the Sunda and Sahul shelves, we find a complex layering of Denisovan ancestry. These ancient genetic fragments, inherited from an extinct hominin species that once roamed the Sundaland forests, are not uniform. Their distribution varies wildly, suggesting that as the sea rose, different human groups were pushed into different ecological niches, carrying varying amounts of this archaic code with them. The presence of these Denisovan sequences is a measurable record of survival. It suggests that the ancestors of modern Southeast Asians didn't just move through an empty landscape. They interacted with and absorbed the inhabitants of a world that was already ancient when the first Homo sapiens arrived. The drowning of Sundaland didn't erase this history, it compressed it. The genetic diversity we see today in places like Papua and the Solomon Islands is the pressurized result of thousands of years of these introgression events, all forced into a smaller and smaller geographic space as the land disappeared. When we look at the out-of-Taiwan model through this lens, the agricultural expansion of 4,000 years ago appears less like a conquest and more like a final layer of paint on a deeply textured canvas. The migrants from the north did not arrive to find a blank slate. They met a highly adapted, genetically diverse population that had already spent 5 millennia mastering the rising seas. The Austronesian identity, which we often treat as a biological category, is revealed by genetics to be a cultural and linguistic overlay. The biological foundation remains stubbornly Sundaic. This leads to a profound recalibration of how we define indigenous. If the genetic core of a population can be traced back to a continent that no longer exists, where does their homeland truly lie? The DNA suggests that identity is not a fixed point in geography, but a trajectory through time. The people of the Philippines, Indonesia, and the Pacific are the living continuity of a drowned world. Their genomes are archives of a climate crisis that occurred long before the invention of the steam engine, proving that humanity's greatest adaptive strength is not its ability to hold on to a specific piece of land, but its ability to incorporate new code and keep moving. The focus on purity in ancestry narratives is a byproduct of cultural mythology, not biological reality. In the wake of the Sundaland submergence, purity would have been a death sentence. The groups that survived were those that embraced gene flow, allowing their lineages to mix and adapt to the rapidly changing coastlines. This is why the search for a single ancestor for the Pacific peoples always fails. There is no single ancestor. There is only a massive churning sea of genetic exchange that was catalyzed by the loss of a continent. The evidence from the Sunda shelf forces us to reconsider the very nature of human bottlenecks. We often think of them as moments of near extinction, but in the context of Sundaland, the bottleneck was a creative force. It stripped away the redundant and amplified the adaptive. It took a continental population and refined it into a maritime one. The genetic legacy of this transition is now being mapped in the very code that regulates everything from metabolic rates to skin pigmentation, showing that the environment didn't just move people, it remade them. But as we sequence more ancient genomes from the region, a new and more unsettling pattern is beginning to emerge. The data shows that while many lineages expanded, others simply vanished into the deep time of the South China Sea. There are ghost populations in the DNA of Southeast Asia, signals of groups that contributed to the modern gene pool but left no other trace of their existence. These ghosts represent the lineages that didn't make it to the highlands or the outriggers in time. They are the silent partners in the human story, their existence inferred only through the statistical anomalies in our own cells. This raises an uncomfortable question about the future of our species. If the drowning of a continent 10,000 years ago could fundamentally rewire the kinetic map of half the planet, what are the implications for a global population currently facing a similar, though far more rapid, rise in sea levels? We are the descendants of those who survived the last great drowning. But the Sundaic code tells us that survival came at the cost of total transformation. The version of humanity that emerged from the waves was not the same one that entered them. The story of Sundaland is not a tragedy of a lost civilization. It is a case study in the relentless, unfeeling engine of evolutionary continuity. It reveals that the stability we crave in our identities is an illusion, provided by the brief 10,000-year window of the Holocene. As that window begins to close, we are forced to look at the Sundaic survivors not as a curiosity of the past, but as a blueprint for the future. The code they carried forward is a reminder that we are a species defined by our migrations, our admixtures, and our ability to persist when the ground itself disappears. Yet, as we move deeper into the genomic record, we find that the drowning of Sundaland may have triggered an even larger, global ripple effect that we are only beginning to quantify. The genetic pulses that moved north into the Asian mainland didn't just stop at the coastline. They traveled across the Bering Land Bridge, potentially carrying the echoes of a drowned tropical continent into the very first populations of the Americas. If the code of a submerged Southeast Asian landmass is hidden within the founding lineages of the Western Hemisphere, it would suggest that the human family tree is even more interconnected and more resilient than we ever dared to imagine. The genetic bridge between the drowning Sunda shelf and the rest of the world suggests that the Sundaic expansion was not a localized event, but a planetary one. As the South China Sea swallowed the lowlands, the resulting displacement triggered a cascading effect of gene flow that reached the edges of the Pleistocene world. When we sequence the remains of ancient individuals from across East Asia, we find that the genetic distance between northern and southern populations began to collapse precisely during this period of inundation. The ghosts of Sundaland are not merely regional spirits. They are the ancestral architects of a broader Asian homogeneity that would eventually facilitate the crossing into the Americas. This realization forces a pivot in our understanding of evolutionary success. We often measure the triumph of a population by its architectural ruins or its written records, the cultural artifacts that survive the passage of time. But in the wet, acidic soils of the tropics, such evidence dissolves. The only high-fidelity record that remains is the one written in the 4-base alphabet of DNA. This molecular record tells us that the Sundaic populations didn't just survive the loss of their continent, they exported their survival strategies into the global gene pool. The high frequencies of metabolic adaptations and immune system variations found in modern Southeast Asians are the functional scars of an environment that was constantly trying to submerge them. In this context, the concept of ancestry as a fixed, romanticized heritage begins to fail. Genetics treats the human story not as a collection of static branches, but as a fluid, braided stream. The submergence of Sundaland was a moment where the braids were forced together, creating a density of genetic exchange that fueled the next 10,000 years of human history. The Austronesian expansion, the out-of-Taiwan migration, and the subsequent peopling of the remote Pacific were not independent movements. They were the late-stage ripples of a prehistoric splash. What we are witnessing in the data is a recalibration of human identity from the symbolic to the measurable. When we strip away the cultural myths of sunken kingdoms and lost tribes, we are left with a population that was incredibly efficient at navigating catastrophe. Their DNA shows no evidence of a civilizational collapse in the way we traditionally define it. Instead, it shows a relentless continuity, a population that simply traded land for water, and in doing so, became the most successful maritime voyagers in the history of the species. This brings us to the ultimate macroevolutionary question. If the most significant shifts in human genetics are driven by environmental displacement, what happens when there is nowhere left to migrate? The Sundaic survivors had the vast, empty Pacific and the rising Asian mainland to absorb their expansion. They had space to dilute the trauma of their displacement into new genetic combinations. But as we map the modern genome against a backdrop of contemporary rising tides, the Sundaic blueprint suggests that our current genetic stability is the anomaly, not the rule. We are a species defined by the pressure of the bottleneck, yet we are currently living in a period of unprecedented expansion that defies the historical cycle. The drowning of the Sunda shelf teaches us that the map of humanity is never finished. It is a work in progress, constantly being edited by the sea, the climate, and the inevitable mixing of codes. The Sundaic signal in our DNA is a reminder that we are the descendants of the displaced, a collection of lineages that refused to stay still when the world changed. But as we look toward the next great shift, the genomic data reveals a final, unresolved mystery. While we can trace the outward radiation of the Sundaland survivors, there is a missing link in the transition from the tropical forests to the open ocean. Somewhere in the thousands of years of submergence, a specific set of genetic mutations allowed for the transition to a purely maritime existence. A biological shift so profound it altered the very way the human body processes oxygen and regulates salt. We have found the descendants and we have found the drowned continent, but the specific moment where the terrestrial became maritime remains hidden in the unsequenced depths of the shelf. What other adaptations are currently lying dormant in our code, waiting for the next environmental catalyst to trigger a global recalibration? If the history of our species is a series of pressurized dispersals from disappearing worlds, then our current global distribution may only be a temporary alignment. The code is already there, vibrating with the memory of the last great flood, waiting for the horizon to move once more. The shift from a terrestrial life to a permanent maritime existence is perhaps the most extreme physiological pivot in the history of Homo sapiens. While the genetic data confirms the displacement of populations, the how of their survival reveals a radical biological recalibration. In the surviving descendants of the Sundaland dispersal, specifically groups like the Bajau of Indonesia, we see the results of a high-pressure evolutionary experiment. Genomic studies have identified a significant expansion in the PDE10A gene, a variant that correlates with an unusually large spleen. In a biological echo of marine mammals, this enlarged organ acts as a biological scuba tank, injecting oxygenated red blood cells into the circulation during deep, prolonged dives. This isn't a cultural tradition of diving. It is a measurable founder effect, accelerated by the necessity of a drowning continent. When the land vanished, those whose physiology could exploit the remaining aquatic niches were the ones who passed on their code. This Sundaic adaptation serves as a case study in how human biology can rapidly specialize when a population bottleneck coincides with a shifting environment. It challenges the assumption that human evolution slowed down with the advent of civilization. In the case of Southeast Asia, the loss of land actually accelerated it. But the genetic evidence also points to a more subtle metabolic adaptation. For populations forced onto a diet consisting almost exclusively of marine resources, the body had to rewire its nutritional processing. We find unique signatures in the FADS gene cluster, responsible for the synthesis of long-chain polyunsaturated fatty acids among coastal Sundaland descendants. This is the same genetic region that allowed the Inuit of the Arctic to thrive on a high-fat, meat-based diet. This convergent evolution suggests that different environments can trigger the same genetic response, proving that the human genome possesses a limited but highly efficient set of emergency protocols for survival. As we analyze these deep time signatures, we move from the micro-evidence of specific mutations back to the macro consequences for the species. The submergence of Sundaland didn't just create the sea peoples of the Pacific, it tested the fundamental plasticity of the human blueprint. It showed that identity is not just a collection of memories or languages, but a functional set of biological responses to external pressure. The people who emerged from the Sunda shelf
were no longer just the inhabitants of a place. They were the inhabitants of a process, a continuous, adaptive movement that defines the modern human condition. The map of humanity wasn't written in a lab. It was carved by the sea and the stone. This is Helix Horizon, where we trace the code that refuses to stay still. By looking at the drowned continent of the East, we see a mirror of our own future, a world where geography is temporary, but the genetic record is indelible. The story of Sundaland is not over. It is still being written in the high-altitude adaptations of the Himalayas, the oceanic resilience of the Pacific, and the migratory instincts of a species that has already survived the end of its world once before. As we stand on the precipice of a new era of environmental instability, the genetic archives of Southeast Asia suggest that our survival will not depend on the walls we build, but on the code we carry forward. If the drowning of a continent 10,000 years ago could trigger such a profound biological and geographic expansion, we must ask ourselves what dormant potentials are waiting to be unlocked in the current global population. Are we, like the inhabitants of Sundaland, on the verge of a transition that will render our current definitions of human and homeland obsolete? The search for the Sundaic signal continues to push deeper into the genomic dark matter, uncovering connections that blur the lines between once distinct populations. But as we resolve the mystery of the drowning continent, a larger, more unsettling question begins to emerge from the data. If the rise of the oceans was the catalyst for the greatest expansion in human history, what was the catalyst for the relative stability that preceded it? And why does the code suggest that even during the quiet periods, we were never truly at rest?